Good morning, guys! Welcome to our vlog! I am Kay Amigable. I'm Agnes Lolo. I'm Jocelyn Namalon.
Today we're going to perform saponification.
But before that, let us know first what is saponification. Saponification is literally means soap making.
A process by which dry glycerides, most often animal fats or vegetable oils, are reacted with sodium or potassium hydroxide to produce glycerol and fatty acid salt called soap. So these are the apparatus to be used in saponification.
In saponification, a fat reacts with a base to form glycerol in soap. Lipids that contain fatty acid esters linkages can undergo hydrolysis. This reaction is catalyzed by a strong acid or base. Saponification is the alkali hydrolysis of the fatty acid esters. The chemical reaction between any fat and sodium hydroxide is a saponification reaction. For example, triglyceride plus sodium hydroxide or potassium hydroxide will undergo saponification reaction to form glycerol plus 3 soap molecules. Saponification is the name of the chemical reaction that produces soap. In the process, animal or vegetable fat is converted into soap and alcohol. The reaction requires a solution of an alkali, for example, sodium hydroxide or potassium hydroxide, in water and also heat. This reaction is used commercially to make soap, lubricants, and fire extinguishers.
First, transfer to the conical vial. Add 1.5 ml of a 50 water and ethanol solution.
A few minutes later.
0.8 of sodium chloride in a 3 ml of water. That to be used later in our transfer of the mixture. Add a condenser and gently reflux the mixture by heating it in a hot plate for 30 minutes. Monitor the temperature closely
Few
to
inches
avoid
later.
evaporation of the ethanol at the end of the reaction period. Some speakers will happen. Test the soap by adding a very small piece of a test tube with 4 ml of water. So this is the 4 ml of water. So we're going to get some piece of soap. Cup the tube and shake it. So as you can see, there's a stability of the bubbles. Add a crystal of magnesium chloride to the tube and shake again. So we're going to add a small amount of a crystal of a magnesium chloride. And then you shake it again. So there is no presence of bubble since we added a crystal of magnesium chloride.
A few minutes later.
So this is the soap of a large one.
Why did we select this method? Is it suitable? Of course, we select this method is because this method is only suitable in making a soap. It is only effective in converting a fat or oil into a soap by action of heat and preserve of the aqueous alkali. What is the chemical basis for this experiment? The chemical basis for this experiment are triglycerides that are reacted with sodium or potassium hydroxide to produce glycerol and a fatty acid cell called soap. The triglycerides are most often animal fats such as lard or vegetable oils such as olive oil. When sodium hydroxide is used, a hard soap is produced. What were the errors encountered during the experiment and how did we solve them? The errors that we were encountered during the experiment was we immediately put the lard oil into a conical vial instead of heating it first. Moreover, the other error that we were encountered was the yellow color present in the soap due to impurities because we're not able to wash first the apparatus, specifically the thermometer that monitored the temperature of a reflux setup. Why is the percentage yield low or high? Usually, percentage yield is lower than 100% because the actual yield is often less than the theoretical value. Reasons for this can include incomplete or competing reaction and loss of the sample during recovery. This can happen when other reactions were occurring that also form the product. The process by which triglycerides, most often animal fat or vegetable oil, are reacted with sodium or potassium hydroxide to produce glycerol and a fatty acid salt called soap.
What did you learn about this experiment? We learned how to make a soap in a simple and easy way. However, it will consume so much time